Hey there everybody, this is Andy from Zenith Game Development. This is the first episode of the Godot tutorial that we're going over for those who either couldn't attend to our live meetings, the online meetings, or if you just want to refresh on some of the things we went over. So, this is the game we'll be making. It's just a little puzzler, nothing really to it, no menus, screens, UI, it's just the game itself. So basically a prototype of maybe a full game that would be more polished. But it has some basic mechanics. Obviously a player, it moves on a grid system. You can push objects, and there's also collision with walls, and these goals basically sense when both of them are pressed. And yeah, it's super simple. Took me about 2 days to write on my own time, but I expect it will take us about somewhere between probably less than a month, but probably around 3 to 4 weeks. So what we're going to be doing today is basically the basic player movement. That's what we got to during our live meetings. So we're just going to be doing that today. And in some future episodes, I'll go about player collision, animation, whatnot. We'll get to that in due time. So, okay, the first thing we're going to do is download the repository. Basically, a repository is a collection of files. If you haven't used any sort of repository or GitHub before, okay, so this one is on GitHub, and it's in the Discord. So once you can't find it or you're not in the Discord, you can just put in github.com/sociopathic/zenith, as you see right here. It's very simple. Once you download the zip file, you basically don't have to do anything else. You can double-click on the program, and it has a little drop-down, and basically get right into game dev. I already have this downloaded on my computer. It is not basically you download it, you unzip it, it's going to have a little pop-up that says later on, you have no projects. Would you like to open your assets folder in Godot, or the asset library? And I'll be talking about that when we get to it. And press cancel. For now, just download the zip. Then you'll be taken to extract this screen, and it won't have all these projects that I have. Once you have it will files downloaded look like this. And in order to make a new project, you just click New Project. And you can download Godot. Give it a name. It's supported on Linux, Mac OS, and Windows. Walkthrough. I already have there's not a ton to it. Tutorial, which it's a self-contained program, so you just download the file and you unzip it, and you're just going to double-click it and open it right up. You don't have to, but I find it the easiest. Odds are you're going to be using the standard version. That's what we're using. Want to route this to a document in the Godot file. Prefer to write in C# or C++, which the mono version supports. Whatever you prefer. Additionally, you're almost certainly getting the 64-bit version to put in the Godot file, so it just goes straight into my documents file. Even older laptops and computers use 64 edit. And it may take a little bit because this is the first time your machine opening up the editor, really should not take too long. So I'd say it's unlikely that you're using 32 here, and if you are using 32 and you download 64, you'll find out pretty quick when the file doesn't work, But yeah, they also have many other editors, and I obviously don't have a Linux or Mac laptop, which deals with what's currently in your viewport here. So project has things there's not much I can help if you have issues, but there are plenty of instructions. You can also export forums about how to set up Godot. It's very simple though, because the only thing I really use in here is it's basically the same as far as I know across the board. So just download, unzip, double click, and you're only when you're dealing with maybe physics or AI. Once you've downloaded editor, I rarely use it, and you've downloaded Godot. Godot is a self-contained program. I've never used the help function. Once you download the zip file, you basically don't have to do anything else. You can double-click on the program after you've extracted it, and basically you have right into workspaces. Right now we're in the first time you open Godot, if it is not going to immediately show this menu, it's going to have a little pop-up that says, you have no projects, and this is what we're going to open the asset. There's also the script or the asset library, and you're just going to be like, once you start making script files, you can open them here and look at them and edit them from within the editor, all these projects that I have. We're mostly going to be using 2D and script. It will relatively look like this. And in order to make a new project, you have just the play project. We don't currently have a scene right now. give it a name. So I'm calling
we're not going to do that yet, but we will get to that
walkthrough.
I already have a ZGD tutorial, which is
the scene tree.
Original
This is basically
file when I was
everything
making
that's currently in our game
at a given time.
And you're just going to click
Godot
uses
folder.
a node
You don't
tree
have
system,
to, but I
which
find it the
means
easiest. It automatically adds it
there
to
is a
documents
hierarchy
file.
of parents and children.
You may want
have
to route
the
this
root
to
node,
a
and then you
document
have
and
all
then
your
Godot
node files
within
in
it
it.
so that it's all self-contained.
But
So
it's very visual
whatever
compared to
you
something
prefer
like
when
hard
it comes
coding
to
everything
organizing files.
into
I just
a game
tend to forget
using maybe a
to put in the
library
Godot
or whatnot.
file, so it just goes straight into
you
my
can basically
documents
drag
file.
and drop new nodes into your scene tree and arrange it the way
And
you
you just
like.
click
So it's a
create
little
and
bit
edit,
easier for
and
non-programmers.
it may take a little bit because this
We
is
also
the first
have
time
file system
for
here,
you opening up the editor,
and
but
this
it
is
should not take too
basically
long.
the folder where
So
you're saving the
there's
project.
quite a bit here,
and you can make subfolders
and
up here in the
whatnot.
top left you kind of have the
I
base
use this
toolbar,
quite a bit. I
you know.
love organizing
Similar to
my
that, like many
projects.
other
It helps a lot
editors,
with
my
whatnot.
productivity personally.
You have seen,
But it's more based
which
on preference.
deals with
Also,
like
up
what's
here you can
currently
click
in your
import.
viewport here.
And when you're
Project
importing
has
certain
things
things
like
project
PNG
settings
files and whatnot.
you're going to
That's
want to
you can also
re-import them,
export,
especially if you're
export
working in
from here.
Pixel, to get the correct
Debug,
display
the only
options.
thing I really
so
use in
that
here is
you don't get like
fuzzy
visible
pixels
collision
and whatnot.
shapes and visible navigation.
There's also over here
but
the
node
it's
viewer has
only
nothing
when
here
you're
yet,
dealing with
but it would
maybe
display
physics or
other
AI
editor. I rarely use it. Take two.
but
On the right side,
I have
we
used it
have
once
the
or twice.
inspector.
I've never
And
used
once
the
we
help
create
function,
a node, if we
but
select
I
that node,
believe
you
you
can
can just
then
search
see
it
it in this
documentation.
inspector.
It'll put all the properties,
then
the
in the middle,
variables,
you
whatnot.
have your
Anything
workspaces.
public.
Right
in
now
the
we're in the 3D
strips of
viewport
it.
of that
If you click
object.
2D,
We'll be able to be
you'll be
seen
taken
in
to
the
the 2D
inspector. There's
viewport.
also the node tab.
I don't
And this is what
believe
we're
we'll
going to
really
be
using
working
the
in. There's
node tab
also
in this
the
project.
script.
However, it's usually
workspace
used
for handling
once
signals
you
from
start
nodes
making
to
script
other
files,
nodes,
you can open them here
which
and
can be
look at
very
them and edit them
useful
from within the editor,
once
which
you
is
start
very
getting
nice.
into more complex scenes that have multiple
We're mostly going to be
objects
using
that
2D
need to
and
be
script.
knowing what the other objects
Then
are doing.
in the
Because
right
this
side
is
of the
such
toolbar,
you have the play
almost
button.
a turn-based
We don't currently have a
puzzler.
scene
You really
right now,
don't need signals
so
as much as you
we're
may
not going to
need
do that
for like
yet,
a real
but
time
we will get to that in
game.
due time.
But yeah,
Then
that's
we
the
have
basic
the scene tree. This is basically
idea
everything
of
that's currently in
the
our game.
at a given time. Anyway, so
Godot
that's the
uses
basic
a
idea
node tree system,
the
which
Godot
means
engine from a
there is a
glance.
hierarchy of parents and children. You have the root node, and then you have all your nodes within it. And so it's very visual compared to something like hard coding everything into a game using maybe a library or whatnot. You can basically drag and drop new nodes into your scene tree and arrange it the way you like, so it's a little bit easier for non-programmers. We also have file system here, and this is basically the folder where you're saving the project, and you can make subfolders and whatnot. I use this quite a bit. I love organizing my projects. It helps a lot with my productivity personally, but it's more based on preference. Also, up here you can click import, and when you're importing certain things like PNG files and whatnot, you're going to want to re-import them, especially if you're working in Pixel, to get the correct display options so that you don't get like fuzzy pixels and whatnot. On the right side, we have the inspector, and once we create a node, if we select that node, you can then see it in this inspector, and it will put all the properties, the variables, whatnot. There's also the node tab. I don't believe we'll be really using the node tab in this project. However, it's usually used for handling signals from nodes to other nodes, which can be very useful once you start getting into more complex scenes that have multiple objects that need to be knowing what the other objects are doing. Because this is such a almost a turn-based puzzler, you really don't need signals as much as you may need for like a real-time game. But yeah. Okay, so first things first, we're gonna do a little, I call it project housekeeping. Basically, we're gonna load in our assets, and we're also gonna change some of our project settings up here in the project toolbar, and set up our project's base needs before we start actually making anything. I find it good practice. Not everybody does it. They do it as they go, but I think it's a good thing to do, especially as beginners. Once you get more experience, you might become a little bit more slack with what you do beforehand and get right into prototyping, but for now I think it's something you should keep in mind. So we're going to create a couple folders. The first one's going to be called assets, so like art, music, sound effects, different resources that you may need. Sometimes I put text files in assets, fonts, UI, whatever. Basically anything that you aren't directly making in the editor, I put in assets, and then I make subfolders. We're not going to be making subfolders today, just because it's not a big project, but yeah. You're also going to be making one called scenes. As I mentioned, Godot is a node-based game engine. However, you can save your nodes into scenes. And it's very similar to a class in other programming languages, in the sense that you can instantiate it into your game. For those who aren't very experienced in programming, basically this means we can save a template of a scene and then load it into our game as a copy. And then lastly, you're going to make one more folder called scripts. I like to have a dedicated scripts file. I know some people who like putting their scripts with their objects that the scripts are for. I'm not a fan. I like having everything separated by type. And we can right-click our assets folder, and you can click Open in File Manager. And basically, this opens it in your file explorer. I'm on Windows. It'll probably be something else for y'all. But yeah, it's fairly similar no matter what. Godot is pretty much the same across platforms for the most part, besides some actual hardware or software differences. But yeah, so what I'm going to do is I have the assets for Zenith on my desktop. So I'm just going to go in. I have the tutorial assets, and I have a few extra assets here that you guys are not going to be using, but basically when you go to the repository, everything you need is going to be there, and you can copy it and then go to your assets folder and just paste it in. You could also cut and paste it, but I'm copying it for the sake of keeping my assets good, just in case the file corrupts or whatnot. You don't ever really want to lose all your work because you didn't make backups of your assets and game files. So now you can see that we can open up this file and we have all these assets. All of these are PNGs except for tileset.tres. Basically this means it's a resource. It was made in the Godot editor. I'm including it because there are some auto tiling features that I don't believe y'all would be ready for yet, but we'll get to it eventually. And so I just wanted to keep that tile set resource so that we didn't have to go through auto tiling and still have the efficiency of having an auto tile. So what you want to do is you want to control click on each PNG, everything except .tres. This is because we need to re-import these images. So we're going to go to our import, and we're going to click preset, and then 2D pixel. And we're going to click re-import. This basically helps with sometimes you get artifacting with pixel graphics, as well as the pixel art gets fuzzy, and this just keeps that from happening. And then we don't have to worry about it for the rest of the project. It's just something you want to do when you first bring in those assets. Also, if you ever replace an asset later on, let's say I made some edits to the cheese.png, I can just recopy that file over, replace this cheese file, and I don't have to re-import the file, which is very convenient compared to some other editors like Unity. I haven't used Unity in some time, but it used to be where if you brought in a new file, even if it was named the same, you had to re-import it, which could be quite frustrating when you're making small changes and then wanting to see how it looks in game. Okay, so now that we've imported our main assets, we can do some of our project settings. So you're going to click this little project button up here, and then project settings. And there's quite a bit here, but odds are you're not going to be using all of these until you've been using Godot for a very long time. I've been using Godot for a couple years now, and I've really only used general, maybe input map, and auto load. There is plenty to do here, but right now all we're going to worry about is general and input map. So you're going to scroll down, and there's this little display section. You're going to click window. Basically, we want our project to be the correct screen size for our pixel ratio. So we're going to set the width to 277, and the height, let me look at my notes. The height is going to be 144. Resize will probably already be toggled. I suggest keeping it on, because this allows your user to put it into windowed full screen. And we are going to scroll down, and there's this bottom section called stretch, and these do a few things. First, we're going to change the mode to 2D. This tells the editor that we're working in 2D and that it should not stretch in weird ways that 2D graphics would usually break and have artifacts in. Additionally, our aspect ratio is going to be keep. This is because we're working in pixel perfect ratio, and we don't want things to become really skewed because it starts to break the game. And because, every sprite's only made of 16 pixels, the pixels will try to separate sometimes, and it's just ugly. And it causes a lot of artifacting. There's also one more project setting that we're going to change that I did not change in the original time I went through this tutorial. But basically, you're going to go to rendering. It's a pretty big section. You're going to go to batching. And down here at precision, you're going to turn UV contract on. What this does is make sure that pixel art tiles, actually it can be used for basically any type of tiled game, regardless of the ratio. And it basically keeps the tiles from separating and artifacting in weird ways. It helps a lot with 2D tile art. And it helps a little bit with this project's couple times where it artifacts. I noticed that it got rid of most of the artifacting, so yeah. Those are basically all of our project settings that we need for right now, and we can start getting into actually making objects. So, the first thing we need to do is actually create a scene in our game. As you can see, it says create a root node. What we're going to do is click a 2D scene. It's going to be called node 2D, but we're going to rename it to main. This is because this object is basically going to hold anything that is currently in our game. So, let's say we wanted a player, a camera, and maybe an enemy. We would put everything inside of main, and then if we change levels or whatnot, main is still retained as we change the scenes down here. So, if we wanted to go from level 1 to level 2, all the nodes that are children of main can be discarded, but we don't lose data across levels and loading and whatnot. It's also something I learned from a while back from another Godot user, that he always put everything in a main node and then use that node to manage his scenes. So that's basically what we're doing. It's just what I prefer. I find it to be good practice, especially if you have levels like you do in this game. So now what we're going to do is we're going to use Control S or go to Project and Save, and we are going to save this scene. We're going to save it in our scenes folder, and you just click save, my bad, and it's saved. And then we can actually finally click our play button. So it's going to bring up this screen, and it's going to say, hey, what's your main scene? And the main scene is basically every time you press the play button, unless otherwise specified, it's going to load up and play this scene. We're just going to click select current because it is our main scene here. As you can see, it's just a gray box. There's nothing special. This is because there is currently nothing in our scene. So, but as long as it compiles and it's working and it's not crashing, then you're doing well. Now we can finally get to making our player. In order to make our player, we're going to put it in our main scene. So we're just going to right click main, click add child node. And then we're going to use the search bar to search up area 2D, which is right here. Just double click it and it'll make a new node. I'm going to rename this, and I suggest you do also, to player, because this is going to be the base object for our player. As you can see, there's a warning here. It says this node has no shape, so it can't collide or interact with other objects. Consider adding a collision shape 2D or collision polygon 2D as a child to define its shape. Basically, a 2D area node cannot function unless you have a collision object with it so that it can detect what is in the area. So what we're going to do is add a child to this node, and we're going to put collision, and down here is collision shape 2D, and that's what we're going to be adding. As you can see, there's also another error, and it says shape must be provided for a collision shape 2D to function. So this is just saying that we haven't assigned a shape to it. So if you go over here on the right side to our inspector, you can now see the properties of our node. This first property is called shape, and it's empty. We're going to click this arrow down, and then click new rectangle shape. So then we can add an image to our player. We're going to add another child node to our player, and we're going to look up sprite, and it's going to be a sprite and not an animated sprite, just a plain old image. And then once you have that, as you can see in the properties, we have texture, which just means the picture of the sprite, and we're going to click on our mouse and drag it over to our texture. And if I zoom in a little bit, you can see that our mouse is now existing. So as you can see, the collision shape is a little bit too big. What we're going to do is we're going to add a grid to our workspace so that we can easily move and set our boundaries to the 16 by 16 grid. So what we're going to do is up here in this toolbar on the workspace is we're going to click use grid snap. It's this one right here. So now we're going to go to snapping options, click configure snap, and you can see here that we have the properties of our snap. You might assume that you'd be using 16 by 16, which in a perfect world this would make sense. However, in the editor, it likes to snap things to the top left corner of boxes instead of snapping them to the center of the grids. So I tend to do half a size smaller than what my actual tile size is so that I can center my objects more easily. There are other ways to do this, but it usually requires adding some properties to your nodes themselves, which is a little bit too much work when it's an easy fix with the grid snap. So now we can actually go to our collision shape and size it down to the 16 by 16 pixels. Just like that. And there you go. There's also another thing you can do with your nodes. This right here is called make sure the object's children are not selectable. I like doing this on any nodes that have children, especially if I'm going to be moving the node around on the screen. And so you just click that. And this doesn't mean that you can't go down here to your children of the node and edit their properties. You can still do that. However, you have to specifically click it in the scene tree instead of going down here and clicking and moving and accidentally selecting like collision shape or sprite instead of the player itself. It makes things a lot easier when moving around objects on screen. So for a game like this where we have multiple levels and we're going to want to be moving the player around depending on our level and how we want them to start, it's a good choice in my opinion. So now we can play our scene, and there's just a little caveat, is when you open the scene, right here in the very top left corner you can see the little foot of our mouse. However, he's not in the center of the screen. So in order to fix this, we have to add a camera node. And a camera node just tells the game where to look, as expected. So we're going to right click on our main node, and we're going to type in camera, and we're going to click camera 2D. We don't need to rename this or anything, and what I do is you go over here on the right side, and you click current, and that's it. I find that making cameras in Godot is much easier than making camera in game engines like Unity. It was something I always struggled with, but with the pre-made camera node, unless you want very specific camera functions and whatnot for your game, you can make a simple camera just by adding the node, clicking current to tell the game engine to look through this camera, and that's it. And if we press play, our scene will save automatically. It'll open the window, and we can go full screen, and then we have our little guy. So We might later on go into more depth about how we can make better cameras that move with the player and whatnot for different types of games. However, with this little game, where the is always within the screen size, I don't really think it's something we need to worry about. So, now that we have our scene set up for testing with the camera so that we can actually see what's happening to our player and whatnot, we can actually add some code. So you're going to go here to your player node and just right click it, and about a third down in the options there's an option called attach script. Just click that, and you may get this situation where it tries to add it to the scenes folder. What I like to do is just type in scripts, and because the script folder already exists in our file system, we can just add it there, and there's no reason to change the name. Except for very few situations, generally your scripts will be the same name as the node themselves. You're just going to click create, and it'll take you automatically to the script editor. So we're going to delete all of this. This is the script editor. You can switch between 2D and script very quickly to test and see how your game is changing as you adjust your code. It's very simple to use. So we can see that our player is extending the area 2D. This is a form of inheritance. If you are a programmer and have gotten into somewhat intermediate content, you'll know what a class is and how inheritance works. But basically this just means because this node extends the area 2D node, it can do everything an area 2D node can do. So it gains its properties and its functions. So now we can start adding some variables. The first thing we're going to do is add the tile size of our game. So in Godot, to declare a variable, you have to use the keyword var, and then you put the name. I'm going to do tile_size. You can also declare the type using a colon and the type name. This isn't required because, like Python, Godot figures out the types of variables based on their values, but I like to do it for constants or other variables where I know the type will not change no matter what. So our tile size is going to be 16. Similar to Python, Godot functions in a way where you don't need semicolons at the end of lines. Instead, you just go to a new line to show that it's a new command, and also it uses tabs and indentation to show when you're inside of like functions and if statements and for loops and whatnot. So yeah. The second variable we're going to be creating is a dictionary. It's similar to an array in the idea that it holds multiple objects, but instead of just a single object, it holds a key and a value, like a real dictionary. The name of the word, and then you have the definition. That's basically what's happening here in a dictionary. And so we're going to name it inputs, and it's going to equal. And then to show that it's a dictionary, you use curly brackets in Godot. And then we just put in the first value. So basically we want inputs to hold all the directions our player might be moving. So we're going to have right, and then the value of this key is going to be vector2 dot right, all caps. This is saying that right is equal to the direction on the 2D axis as right. It's basically vector2.right is a keyword. I'm sure it's more complex than the way I'm putting it, but basically it just means to the direction of right on a 2D scale. Just put a comma to show you're having another one, and then you can put left, and you do this for each direction. Vector2 dot left. Then up. And these can be in any order you want. I just happen to be doing it this way this time. I'm sure I change it every time I present this tutorial. And then down. So these are going to be matching some inputs we add to our project, and we're actually going to do that right now. What you do is you go to project settings, and we're actually going to go to input map instead of general. And as you see, there's quite a few inputs already here. There are actually some like UI left, UI right. However, we're not going to be using those. We're going to be making our own. So you add each direction that you added to your inputs dictionary in the same way you wrote it. So I wrote mine in all lowercase, so I'll be doing right, click add, left, up, down. As I mentioned earlier, these also don't have to be in the same order as you put them in the dictionary. They just need to be spelled exactly the same. It is case sensitive. And then, once you have them all, they're going to be at the bottom, and you can add keys to them. I suggest using key and not physical key, because if your player is ever using an emulator or something along the lines, or a virtual machine, physical key only works with like a physical keyboard. So if you ever virtually use the key, it will not work. So yeah. And for our right key, we're going to click right arrow, and you have to click OK. You cannot press enter, because enter will just change the input. I'll show you real quick here. Because if you press left and then you press enter, it will change the input to enter instead of left. So you do actually have to physically go and click the OK button. We're just going to do that for every single input. And this is just linking the... I accidentally clicked physical key there. My bad. This is just linking the keyboard inputs to the names of the input, basically, so that when the editor realizes that a key has been pressed, it knows where to send it. So now you can just exit out and go back to your code, and we have a little bit more to do, but we have our dictionary complete. So now we can actually start making a function. The first function we are going to write is actually from a pre-made function called ready. So go down a couple times, and in order to declare a function in Godot, you first write func, and ready is a pre-made function. It must be spelled the way I am spelling it right now. As you can see, Godot was already suggesting that I use ready, and you can press tab and it will automatically fill that out for you. And so in our ready function is called as soon as the player node is loaded into the scene. As soon as the computer loads up the game and the player node is loaded, it's going to call this ready function and do whatever we want in it. So what we're going to do is we're first going to snap the character to our grid. So we're just going to go position equals. By the way, position is a keyword. All nodes have the position property, and it can be changed through code. So this is not a variable that we are declaring. It's a variable that is already declared by the game engine itself. And we're just going to put position equals position dot snapped vector 2 dot 1, all caps, times tile size. Make sure tile size is written in the same way as you wrote our tile size variable up here, and then divide it by 2. What this is doing is it's taking the position of our character right now, it's snapping it to the vector 2, 1. And what vector 2, 1 is it's basically x1, y1 on the vector 2 grid. And then we're multiplying that by tile size and dividing it by 2. This is centering our character in the middle of the tile. So now that we have that done, that is all we currently need in our ready function. So we can continue onward. Next thing we want to do is we want to be able to handle our inputs so that we can actually move the character. Because if you press the play button now, it actually won't do anything. If you press your keys, your character won't move. You have to code it into your program so that it knows what to do when these inputs happen. We're going to make another function, and this is another pre-made function. As like the ready function, it starts with an underscore, which is a naming convention of Godot. So we're going to write func again, as we did earlier. We're going to do an underscore, and we're going to write unhandled input, parentheses, event, and then a colon to show where our definition continues into. So what unhandled input does is there are two other input functions. One of them is just called input, and the other is called GUI input. Same convention as this one, where the parameter is the event. But what happens is, first, the input function can take in any input. It has priority to the other two functions. GUI input is any input that isn't handled by input and should be handled by the GUI, so like clicking on a menu and whatnot. And then the third one is unhandled input, which means any input that isn't handled by input or GUI input. Basically, we're using unhandled input because we are doing movement for our player. So, what we're going to first do is we're going to make a for loop. And what this for loop is doing is it's going through this input dictionary we made up here. And we're going to say for direction in inputs dot keys. So what this statement is doing is it's saying for item in inputs keys. And the keys in a dictionary are these left values, these leftmost values. So it's saying for each right, left, up, and down, do something. And now we're going to write the do something. So what we're going to do is we're going to compare our event that this function takes as a parameter, and we're going to compare it to our direction and see if it matches one of our directions up here. And if it does, we're going to do something. So we're going to put if event dot is action pressed direction, and then we're going to put true. And then we're going to put a colon at the end and tab in. So what this is saying is if this event is a pressed button and that button matches one of these leftmost values, and the true is saying that you can hold down the button and it still takes the input. This is because later we want it so that we can hold down our keys and have our player be moving continuously. And it checks all this, and if the event is one of the directions, it's going to move the player. So all we have to write now is move, inputs, square brackets, and then direction. The way dictionaries work in Godot is that in order to get the value of a key, you use square brackets, similar to how you would in a list or an array. So let's say direction was left. It's going to go to inputs, which is this. It's going to check left, and this call to left is going to return this value, the value of the key. So what it's giving us is the actual direction of left, which is vector2.left. And it's returning that to our move function that we're about to write. So now we just write our move function, and it's going to be func move and just direction, and then a colon, and you tab in. And now this is going to be super easy. All we're going to do is position, which is the position of the player, plus equals, and basically plus equals is like saying position equals position plus something. Okay? And so it's just an abbreviated way of saying that we want to increment our value instead of it equaling a value. So we're adding to the current value of position. We are going to do direction times tile size. And this just means that it will move in the direction that we give it in the function parameter by 1 tile size, so 16 pixels. And if we play our scene, if we don't have any errors in our code, we do have an error in our code. And I think it is, yep, a misspelling of mine. I accidentally capitalized action in is action pressed. Always double check your spelling, as most compilers are not very forgiving. And now we'll try again. So it seems to be working. It compiled fine. And if we use the arrow keys, our player moves. And this is about as far as we got to in our first session. Also, if you hold down your key, he goes turbo fast. And yeah, this is as far as we got in our tutorial on Thursday in person, so I won't be going any further. And I'll see you guys in the next episode. If you have any questions, reach out to me on the Discord. If you haven't joined the Discord already, I definitely suggest it. It is how the club gives most of our announcements about meetings, and it's where I answer questions the fastest. And yeah, feel welcome to message me whenever. I'll get to it as soon as I get the chance. If I'm not online, you can also message Angel, our VP. But odds are, if you have a coding question, it's probably best to come to me or another programmer in our club. So yeah, I hope you enjoyed, and we'll start getting into some fun, exciting things next meeting. So thank you for coming.